objects follow the ecliptic.
Yes.
They're simply at different points in the ecliptic throughout the year. When the sun is high in the summer, the moon is going to be on the lower portion of its on the ecliptic during its nighttime cycle. And the reverse is true then for when the sun, this time of year, when our sun is low, you're going to get the moon is going to appear high on the ecliptic.
Okay, we're going to give Bob the hula-hoops in that case. For sure. Thank you, Bob. You have a question?
Well, I was just following up. It's the same reason why there's not a total eclipse every month.
Right, right. How many of you have been asked by your friends why there's not a Mercury transit of the sun, you know, every year when we come back around and catch up? Well, every year when we catch up with it. Same thing.
Or 3 times a year, because that's how often it passes.
Yeah, okay. Well, yeah, we helped Elaine buy eyepieces earlier. Yes?
I think I learned at one point that Mercury has a weird orbit due to like
Relativity?
right?
Yes.
Is that one of the reasons why we don't see it as often?
No, it's not, but it's a really interesting topic that I'm going to talk about now because I like it. For a long time, we thought there was another planet closer to the sun than Mercury called Vulcan. And because Mercury's orbit appears to be perturbed, and we thought there must be something else. It turns out regular Newtonian physics cannot accurately determine Mercury's orbit like it does for the other planets. And the reason is Mercury is so close to the sun's high gravitational field that we needed Einstein to come along and improve our equations a little bit. So very cool. Sorry, if you give me a chance, I'll talk about anything.
Wasn't there an eclipse or something that happened way back that proved that?
Well, yes, during an eclipse, they were measuring the bending of the starlight next to the sun. So, yeah, because when Einstein published this paper, they were like, oh, that's interesting, and it makes a prediction, but that's going to be really hard. And Robert has something to add.
Well, no, just brought to mind a question I was asked recently about the Einstein cross, which is the image that you get when a quasar is imaged behind a galaxy, and the sunlight is bent around that galaxy, and you get 4 different representations. But so I was asked, well, why don't we just get like bending so that you'd have like a circle of light? Why is there specifically 4 images above and below and right and left of the galaxy of the quasar behind it where the light is being bent? And I couldn't answer
I've
that.
actually always wondered that myself.
I do not know the answer to that question. I only took 2 semesters of physics. This was engineering.
I believe that would be due to the shape of the lensing galaxy.
The shape of the lensing galaxy is an excellent hypothesis because the gravity is it's not a point source, it's distributed. So that would have an effect.
And there is Einstein circles because the lensing galaxy is spherical.
There you go. I know there's a couple lines. There's at least one you can see in the telescope.
Right?
Yeah.
There is. Okay.
Yeah.
You mentioned religion earlier. Do you know what type of telescope Jesus used?
Oh boy. And with that, it's actually 7 o'clock, which is the official 7 o'clock is the official start time of the meeting. So, hello. You guys had the poor judgment last meeting to elect me as your new president, so now you get to look at me every month. So, all right, so welcome. So first, I want to recognize any brand new members. Raise your hand if you're a brand new member. Hello, welcome new member. Would you mind telling us about yourself?
Hello, my name's Kevin Hine. Not sure what you want to know. Just figured I would give this a shot. So here I am.
Well, welcome. You didn't intend to join the astrology club by accident, right? Okay, then you're fine with us. Welcome. Very good. Any non-members who are just first-time visitors, so we can make sure we try not to scare you off. Do you mind introducing yourself?
No.
Okay.
I'm Keith Rexius.
Hi, Keith.
Winter Springs.
Winter Springs.
I'm an amateur SETI guy.
Amateur SETI guy. That's fine. That's very good. Cool. Cool. I had a friend a long time ago. He had a basement full of computers, all running that SETI home screensaver. His electric bill was outrageous. Yeah, that's pretty crazy. So in the announcements, a few announcements to make. The first announcement is about our AstroFest Star Party, our annual AstroFest Star Party. We have been planning to hold that at Forever, Florida. It is one of the best Star Party sites, in my opinion, that we have ever gone to. And I get to travel professionally to Star Parties all across the country, and I could say it is a really good Star Party site. Notice I said was past tense. Unfortunately, Forever Florida has ceased all public operations, and they're only operating as a wildlife preserve. This is due to a death in the family, so it's sort of non-negotiable as far as trying to talk them out of that. And so on the board, we've been scrambling to try to find another place to hold AstroFest because we still want to do it. And it seems that with such short notice, Chiefland is probably going to be where we're going to hold it. The dates are the same in January, the 23rd, 24th, and 25th of January. The 24th is actually New Moon. So we're going to do it at Chiefland. We don't have a lot of details yet. We'll have some details about that at the next month's meeting at the holiday party. If there's a silver lining at all, it'll probably be cheaper going to Chiefland versus the Forever Florida site. How many of you don't know what I'm talking about when I say Chiefland? Okay, so Chiefland is an astronomy village up and to the west of Gainesville, Florida. It's sort of close to the coast, but not super close to the coast. It has reasonably dark skies, and the whole neighborhood is dark sky. Everybody's got observatories, and they have some public areas where you can go and camp. There's a couple of cheap hotels in town if you need a place to go hide during the day. It's not going to be quite as good as the Forever Florida site was, and we'll keep looking for sites to hold AstroFest. The other alternative is KPP, and that's something maybe we'll talk about next month. Kind of get some members' opinions about where we should go. Yeah, Derek.
All the campsites at the astronomy site are booked that weekend.
Oh yeah, we can't do it at KPP this year. It's totally out of the
Okay,
question.
just wanted.
But down the road, we might decide to go back to Kissimmee Prairie Preserve. It's a nice state park. It's further south. The skies are a little better, but the bugs are bad. And anyway, it's trade-offs whatever we do. Ken?
There's power all around the field.
Oh, and there is power at Chiefland. So there's some perks to Chiefland. It's not super dark. It's not super far away. It's 2.5 hours, roughly. Yeah, I think it's about 2.5 hours. Chiefland is a real city, so there's a Walmart, a McDonald's, and all that sort of thing. So you're not. The KPP is a little bit remote. If you need to run out and get a bag of ice, you'll be gone most of the day. So there's that. Anyway, this is not the time to debate all of that. AstroFest will be at Chiefland, and we'll have more details for you next month. But the dates are the same. So if you get the dates on your calendar, that's great. If not, put them on your calendar. Next month, of course, is our holiday party. It is going to be over at the Student Center in a room that I forgot to write down, but it'll be easy to find because we'll have some signs up that say CFAS, a holiday party. If you remember, a couple of years back, we held a few meetings over there, so it's going to be in the same place, and they allow us to bring food and things. We're going to cater, so we're going to bring in some sandwiches from Publix and that sort of thing like we always do. We also would like you to bring a dish, something that you just like to make, or something that you just like to buy at Publix. For me, it's those hot and spicy chicken wings. And I did marry into the Colonel Sanders family, so technically it is sort of it's a legacy for my family. The one thing that we do really want to emphasize this year is take your leftovers home. You might think, oh, I'll just leave that and somebody will take it. No, please don't do that. Please take your leftovers home. The last 2 years, we've had a huge amount of stuff that we had to throw away and clean up, and it's if everybody just takes home what they brought, or their plates and all that sort of thing, and if you leave any bowls and utensils behind, you should not expect to ever see them again in this lifetime. Yes, sir.
Date and time?
Date and time. It is second Wednesday of December. The number is not on top of my head. The same time as our normal business, our normal meeting, 7 o'clock. I know last couple of years we did it at Geneva. December 11th. The last couple of years we did it at Geneva. because it lines up nicely with the meteor shower, but it's really close to full moon, so there's not going to be much in the way of meteor shower. So we decided to just go ahead and have it here. It's closer for most people anyway. Kent has Astronomy magazine calendars for sale. They're $10. You want to hold one up, Kent? There we go. We do this every year. $10 for astronomy calendar. I also, John Pinto, are you here? There he is. The Astronomical League also makes calendars, and John wanted me to check with the membership in general. If anybody's interested, we do get a discount if we buy more than one at a time. So if you have a preference for this over the Astronomy League, and of course I have one here if you want to look at it after the meeting, that'll be fine. So, what else? The Mercury transit was great. If you missed it, I'm very sorry. A number of us participated up here at the Student Center with the college. Yes?
I have one announcement to make. I brought some astronomy magazine species, and they are in the corridor.
Oh, okay. So there's
Free. Okay, I just read it once, so everything is in class.
free astronomy magazines in the corridor. Okay, very cool. Thank you for doing that.
You're welcome. Anytime.
Richard,
Well, at least
can I
you
make-
run out of magazines.
we have a couple people coming in. If you guys don't mind, if you're on the very edge, if we can kind of scoot over a little bit so we can let some people come on in. Don't worry, everybody. I don't think bites, right?
Are you new members? Yeah, new members. You don't get out of it just because you showed up late. Welcome, new members. Do you mind telling us about yourself?
My name's Bricks Milner.
Bricks?
Mike Lizzie.
Lizzie, nice to meet you both.
We just moved back here from Nashville.
Okay.
We were here before, but we just moved back and
All right.
moved
Lived
up
here.
right away.
All right, you came back home then. Very
Yes.
good. Well, were you a member of CFAS when you lived here previously?
No.
Okay.
And,
No, not a country star. All right. We had a great turnout for the Mercury transit here. I know we had some other events. Does anybody want to report on other events that they were attending or volunteered for this month? Yeah, Elaine?
The Halloween event at Orlando Science Center.
The Halloween event?
That was
Wow,
for
has
kids.
it been that long? Yeah.
Kids.
Yeah, we did just get past Halloween. Okay.
It was a lot of fun. The sky cooperated pretty well.
It's always good when the sky cooperates.
And,
Yes.
Yeah, Derek and his sidekick there were really characters. And yes, and I will forever call Mauricio Carl.
Okay.
I dressed up as Carl Sagan.
Oh, yes. Well, you were Carl Sagan at the spooky thing here too. Very good. That's awesome.
But lots of children and
Okay. Very good.
the adults also. Woo.
Very good.
Yeah, the sky really couldn't have been better.
John?
Is there going to be a public winter star party this year or next year?
So a public winter festival, we have always helped out with the Planetarium. We should probably ask the Planetarium director.
So the answer is no, but there's something replacing it. Between Mercury Transit and Spooky Star, our bandwidth is crazy. But we are going to be doing a winter star party at Geneva on the 18th of January, whatever that, and so somewhere at that time. So yes, we are going to be doing an event. It's going to be a big thing. We're going to have call for CFAS members and do something over there.
Sounds good.
This is a good segue into something I just want to mention. How do you know what's going on at CFAS? How do you know what's going on when we're going to do this or that? Mostly it's through our Facebook page. And one of the topics I want to bring up next month, so I'll let you percolate about this. Everybody doesn't like Facebook. Some people think Facebook is evil. That's okay. Some people think Google is evil. That's okay. But we need to find a way for all of us to communicate in some sort of an efficient way so that we can send out news blast alerts. When the ISS flew in front of the sun, no, it flew in front of Saturn recently. There was an impromptu gathering on Facebook. We need a better way to communicate with all of the members. I'm not sure what that is. I have a few ideas, but I'm going to give you guys, we're going to kind of crowdsource this. I'm going to give you guys a month to think about it, and we're going to talk about it at the holiday party. There's Groups.io, which a lot of people are moving to, which is pretty cool. Professionally, I use things like Slack and WhatsApp. So there's a lot of technological tools that we could use where we're not being mined for our marketing data or having our minds read by the Antichrist or whatever it is that we're worried about that's going on there. But you know, one question I should ask is, does everybody have email? Then you don't have, does anybody here not use email at all? Okay, that means all of you are on a computer. That's good. My mother doesn't use email. So I mean, it's not that unusual. So email, it's safe to say something online is a good resource. Okay, very good. Any new business from the members then before we start our mini programs? I'm going to do this every meeting too, by the way. I'm just, after all these announcements, anything new members want to bring up or bring to the attention of the rest of the club. Lynn?
Sure. Yes.
Come on up. The microphone.
Our last outreach report, I'm very happy with. We had 8 events scheduled, 2 of them got canceled, so we only went to 6 events. But those 6 events were covered by 36 individuals throughout the month for a grand total of 192 man-hours. I think that was wow. I want to thank you all very much.
Thank you, Lynn. Justin, come on down. Outreach is very important. I'm going to talk about that in a future meeting.
We've got, is it next weekend? November 22nd and 23rd, Geneva Dark Sky Nights. For those that don't know, Seminole State College has a campus over in Geneva, and it's got a beautiful open field. Bugs aren't too bad, but the skies are great. And once a month we do an event where we have a CFAS night, CFAS only, we get the whole field to ourselves, and then a night that's open to the public, a public outreach event. So the next Geneva Dark Sky Night is the 22nd. That's a Friday night, and it's a CFAS only event. So everyone is invited to bring their scope out. Generally goes from about 6 to midnight, but we go until everyone gets tired. So I'll probably open up the gate around 5. You can get there around 5 and be ready, have your scopes ready by 6. So it's a great location. For those that are willing to come out on Saturday, Saturday's open to the public. Derek and I will be out there anyway with the scopes here for the college, and we're going to be doing some night sky tours, constellations, and things like that, teaching people how telescopes work. But if you're more than welcome to bring your scope out and help us out. We usually get around 150 people over the course of the night. We haven't done one in a while, so I'm expecting if the skies are clear on the 23rd, we should get a decent crowd. Yes, sir?
On a dark sky night, is there power?
There is no power. Good question. Yeah, you need your own power.
So did I hear you say that we're supposed to do that every month?
We've got it scheduled for November, December. Do we have one for January? We do, and then we also have January. Then we transition over to Canaveral National Seashore also. So we've got one night. I think we're in Canaveral and Geneva, and like Derek mentioned, I think we go all the way through March. So we got something at least once a month for CFAS members and the public.
Do you just not bother during summer because of the terrible bugs?
Yes.
That and it doesn't get dark until 10 o'clock at night.
Yeah, our last one of the spring was Eric, I think, Elaine, and I, and we were chased off by huge bolts of lightning. So yeah, but the winters are great. So so just earmark that date. 22nd is CFAS only. 23rd is CFAS in the public.
For the Saturday event for the public, what time would you recommend we get there with telescope?
Well, this right now it's published 6 to midnight. I'll probably open the gate around 4. So if you want to get there as early as 4, you could. Yeah.
Set up in the daylight.
Yeah. Absolutely. All right. Yes.
One more question. I read about the site and I saw it's like a gun range where they train a lot of law enforcement up there.
You have to be quick.
Don't get lost.
Yeah, the directions are pretty good. I don't know if we've gotten anyone too lost, but we've got some pretty
We'll
good
send an
directions.
email with the address.
Well, what I was gonna ask was, is that a feasible place for any of us to go out privately with like a permit, or is that?
No.
Oh, no,
unfortunately, no,
yeah. We have to coordinate it with the school and set up the dates in advance.
We have to have a Seminole State employee at all times, which means that, yeah.
But it's great, you set up your scope, and while you're looking, you just dodge bullets on the gun range.
Hey, Mauricio, if you throw me a little bit, a little Benjamin.
Right. But no, they're completely separate. Gun range is over here, and we're way over here,
We're on
so.
the driving range, you gotta dodge the cars.
Yeah.
Can I make?
It looks like an airstrip, actually. Yeah, Derek.
I wanted to bring up, since I'm the, I also serve as the observing chair for CFAS, and I wanted to kind of do a little crowd survey. So obviously with Forever Florida not being an option, what we used to do is offer observing nights at Forever Florida, ad hoc observing nights. There is another wildlife preserve nearby called Bull Creek, and a group of us have been going there to do night sky photography. But on the way there's actually a fairly large field area where campers hang out. There's also a bathroom over there. And the skies are fairly dark out there. It's actually similar to Forever Florida darkness. There is no power and all that, but as far as an ad hoc observing site, I wanted to kind of just get an idea. I was actually thinking about pursuing somebody from the wildlife preserve about maybe actually having CFAS involved with maybe some type of astronomy, maybe dark sky weekend, kind of similar like we do at Biolab Road, which is a site over at Merritt Island. Just out of show of hands, how many of you would be willing to use that as a site for a little bit darker, more it's near St. Cloud, all right? It's about near St. Cloud, about an hour and 25 minutes from here. So from here, yes, yep, from here. All right, so quite a bit of you. Okay, so it's good enough to. So I'll go ahead and start pursuing that then, and hopefully we'll find another site.
Yeah, it's a good option. Thanks, Derek. Okay, so mini programs. We are so fortunate. I think one of the coolest things about our astronomy club is we meet in a planetarium. And what's the point of meeting in the planetarium if we can't get a planetarium show every now and then? So in addition to tonight's main program, which will be Mercury, Protocol Mercury, Derek is going to give us a night sky tour. And I hope I didn't surprise Derek and he's ready.
No,
If not, I can
my microphone is all tangled up.
Okay.
Actually, while we're waiting, Justin's going to go ahead and close the doors because we need to be absolutely dark in here so we can maximize the amount of starlight we can see. Just want to let all of you know that during this time, it's only about a 10-minute program. If you do leave during this time, unfortunately, we can't allow you back in. Okay. All right. Hopefully he'll.
But you can come back in afterwards.
You can come back in afterwards, yeah. So. What's that?
Yes.
How long are you going to be? 2 minutes? All right. Well, it's up to the president. Are we allowed to wait 2 minutes? Okay. All right.
Well, then while Derek is getting ready, what can I talk about to kill time? All right. We didn't have any other issues from the thing. You know what? Oh, yes, sir, Carl. That's going to be your name from now on, by the way.
Yeah,
Carl.
this is a weird question, but has anyone had like any bear encounters?
Has anyone had a bear encounter?
Yeah, while
I did in the Grand Tetons.
So like here in Florida, while observing.
I do know that Vince White and a few others over at Ocala had a few bear encounters, but
that's always on my mind when I'm out in like the state forests, you know.
Yeah, I hate to say don't bring food with you because you need food, but yeah. Yeah, I think that sometimes people are more dangerous than the wildlife sometimes, for sure. Very good. All right. Yes, Elaine?
Are there any other special viewing opportunities coming up? We just had the Mercury transit.
Special viewing opportunities.
Is there anything else special happening soon?
Yeah. Anything special in the night sky coming up? Crowdsourcing? First quarter moon? I love first quarter moon. I think that's great for looking at the moon. Yes? 5:15 in the morning, the space station is flying over. All right. Spot the station website. Mm-hmm. Okay. Okay, and if you didn't hear what she said, you can sign up on that website. You give them your location, and they'll send you an email whenever the space station is going to fly over. There are several sites that do that
bridge.
It's really cool. Mhm.
The space, I mean, the spacefaring that I recommended this as weather.
Oh, Astrophotography.
Yeah, and they are showing daily what the.
They show ISS passes too?
Yeah.
Oh, very good. Plus you get the weather, Astrophotography. Yes.
I got Sky on my phone and you can program it to track the ISS and such.
Sky?
It's Sky something. My
Sky Safari, maybe?
Safari.
Yeah, Sky Safari.
Whatever it is, it's free.
Yeah, Sky Safari, if you got an iPhone or an Android, Sky Safari is usually my go-to. When people ask what to get, it's probably the easiest one to use, and it's free, so it's pretty good. Are you ready to go, Derek?
Ready.
Because our passenger came back, so I'm going to go.
All
sit down.
right. So, just want to let you all know that planetarium shows are free for CFAS members and families. So, if you like what you see here, it's only a 10-minute program, but we do a full night sky tour program every first, third, and fifth Friday of the month. So definitely come back if you like what you see here. But what we're going to do is we're going to go ahead and bring the lights down. We're going to start with some light-polluted skies here to get us kind of reacclimated to being in the dark. So this is the sky that we would see. Now, of course, this is pretty close to what we will, just a little bit more here. We just need to, I have to switch the projector a little bit here for our full dome presentation later. All right, so first things first, before we start looking in the sky, we do need to go over our cardinal directions here. So right now, in the front of us here, we have which direction? South. Okay, we come over here to this direction, we have east. And we go over here, we have west. Now, behind us we have north, but don't worry, I'll actually move the sky around so you don't have to twist your neck. All right, I know some of us don't have that yoga pose right down, so we're actually going to move the sky around to the north so we can point those out. So this is pretty much very close to the sky we'll see here in Central Florida without a light pollution, but because we are astronomers, we want dark skies. So we're going to go ahead and take a quick trip down to Kissimmee Prairie Preserve and see our skies as we would actually see from that location. So we'll go ahead and kill off that light pollution so we can see the real sky there. Much better, right? Yeah, look at that. Now we can see this beautiful Milky Way band across our sky. Of course, billions of stars in our Milky Way. That's the first thing you're going to notice. The other thing you might notice in the sky as well is you might notice a bright light lingering over in the western sky. You might see something called a zodiacal light, which is actually little particles from the interplanetary dust in our solar system lit up by the sun. In the orbital plane of our planet. So if you ever see this big column of light stretching up from the western sky, that's what that is. It's called the zodiacal light. So you can only really pick that out. We have seen that a few times at Geneva during the darkest and clearest or crisp, less humid nights when the transparency is good. All right, so the first thing we're going to notice is we're going to look over here to the west over here. And we'll see the three stars. Of course, we connect these three stars, we get a shape. That is the square.
The summer square, no, the summer triangle, yeah. So we can still see the summer triangle for just a few more months. But this is getting pretty low, so be sure to grab this part of the sky with your telescope and observe that area because we're going to be losing that. The first up, I knew that was going to happen. I have the projector still on, so I need to kill that. All right. So, first things first, what we're going to notice is if we go over here to the bottom right, we can see the bright star Vega. And Vega belongs to the constellation right here, Lyra the Lyre. Now, for many of us here, I don't know about you, but that doesn't very much look like a stringed musical instrument. Some people pick this out as an earring, so you can see there's the gem with the earring post right there. But what I see here is I see an old-fashioned cell phone back from like the 1990s. There's the brick with the antenna sticking out from the center there. Now, over here, just below, in between these two stars of Lyra, right here is a little nebula called M57. That is the Ring Nebula. And it's a nice little planetary nebula, very bright. Even you can somewhat see it here in light blue skies, but it is a great target to look at, even in a much darker sky. Very, very nice. It's a large
are larger planetary nebula. Planetary nebula essentially is a dead star about the size of our sun that has basically fallen apart, and the inner core of that star has turned into a ball of carbon, and that carbon is releasing a tremendous amount of light, which fluoresces the gas around it, which creates the glow that we see. But early astronomers saw it as like a planetary look. A lot of telescopes that were too small to really see detail saw them as they look like planets, hence why they called them planetary nebulas. So here we have Lyra right here. If we go over here to the top star of the triangle, this is Deneb. And Deneb in Greek literally means tail, which is the tail of Cygnus. But an asterism here that we can see is called the Northern Cross. So here we have a crossbar with another vertical crossbar. But right here represents the tail of the swan. We have its wings here, and down below here we have its tail. Now, over in this part of the sky right here is part of what's called the Cygnus Loop. And the Cygnus Loop contains a huge supernova remnant that many parts of that are viewable with special filters like hydrogen beta filters, as well as oxygen-3 filters. And this is called the Veil area. So basically a supernova remnant. There's the Western Veil, Eastern Veil, and various other areas part of Cygnus. Over here, just above Deneb, is what we call the North America and Pelican Nebula. So over here, actually, if you have a pair of binoculars, you might be able to see a little definition of it, but this is a great astronomical target to photograph in the sky. But if you have a smaller telescope and you want to see something cool, right here, this star right here is called Alberia. But of course, to our human eye, Alberia looks like one star, but looking at it, we see two. We see one gold and one blue star. Here at Seminole State, we call those the Seminole State stars because our colors are gold and blue. Our president really likes that when we mention it in the show, so you never know, she might be hiding around here, and we always have to say it by trade. But that is Alberia, beautiful star, binary star system, great to look at, especially during an outreach event. If you want to show somebody something really neat that's not a planet or the moon, you can show them Alberia, and they just love to see the colors of those stars using the telescope. So here we have the summer triangle right here. That's again a very nice object to see. Another thing we can see right here is this little band of stars. This is called Sagitta, the arrow. So that's another great way of kind of picking out some of the more fainter constellations. Right here, just kind of between, I forgot to mention the last star. Oh, there we go. The last star of the triangle right here, that is Altair. And Altair literally means flying eagle in Arabic. And that's exactly what it is. It's an eagle. This is the eagle's head. This is Aquila, the eagle. There's its head. We have his wings here and his tail. So our eagle is soaring across the sky there, ready to look for somebody to eat. No, I'm joking. They're not going to eat. All right. So here we have the beautiful star Altair. We have a supernova that went off here in the planetarium. Everybody see it? It only lasted for just a few seconds. Now, above Altair right here is this little constellation called Delphinius the dolphin. Isn't he cute? Oh, there's his head, and there's back fin. There he is, flying, swimming around in the sky. Now, I want everybody to look up towards part of the sky called the zenith. Now, in astronomy, the zenith is our highest point in the sky. If you're having a hard time finding it, you look straight up. That X that marks the spot right there is our true zenith here in the planetarium. Wouldn't that be awesome to get that in the real sky? Yeah, wouldn't that be great? Yeah, it would be nice. Even these letters would be really nice, wouldn't they? You're driving around, you're trying to find something, you're like, look for the giant S!
No, too bright.
Not too bright. Well, we can dim them down. We can dim them down. All right. We can turn them red, too, if we wanted to. All right. Now, zenith. The zenith here, what I like everybody to do here, we're going to notice 4 bright stars right there. Those 4 bright stars represent the great square of Pegasus. All right, so that's Pegasus right here, and so the head of Pegasus actually is. If we go to this bottom right star right here, we connect down there. There's his mane, and down here we have the star Enith, which is the nose of Pegasus. So here's his head, there's his neck, and up here we have the star Migras. Right here we have the the feet of Pegasus right there. So you can see him galloping. Now he's upside down because he's a flying horse. And how many of you, if you flew, would fly upside down? Exactly, right? Yeah. So now, what I'm going to do here is I'm going to go ahead and start moving the sky over to the east. Now, if anyone gets motion sickness, please close your eyes. Housekeeping doesn't clean up here. I do. So I don't want to have to worry about any space debris in the planetarium at the end of the program here. So I know Justin and I are not going to be happy about that. Right, Justin? Is he still in here? He's not in here. Okay, sorry. All right. So this bottom left star of Pegasus is called Alpheratz. And this star right here connects to another constellation. You can see there's 1, 2, 3 stars that are in a line. That represents the right side of Andromeda, the princess, right here. So here we have the Pegasus. The bottom left star represents Alpheratz. And over here we have Andromeda. Now, we have another couple of stars here that kind of make up another line. That's the left side. We can see it's supposed to be a princess that's chained to a rock. She's about to be eaten by a monster, Cetus. So that's her arms chained up here, and it's her body and her legs and her feet. Now, what I'd like you to do is, we have the star Alpheratz. We have the middle star. What we want to do is we want to go just above it. Now, if you look carefully right here, you can see almost a faint patch of light. Does everyone see that faint patch of light there?
No.
If you are having a hard time seeing it, one of the techniques that we use in astronomy is what we call averted vision. We're going to use the side of our eye. So we want to look over here, but focus our attention. We're using just a little bit extra rods that actually enhance our eyesight. And you'll see the Andromeda Galaxy right there. And the Andromeda Galaxy is the farthest object that we can see with our unaided eye, our naked eye, as we would say. And another supernova. Another supernova. Man, boy, gosh, that's a lot of supernovas. We can actually calculate that the universe is accelerating from these supernovas that are going off in the planetarium. All right. Now, here we have the Andromeda Galaxy here. Again, the farthest object. Well, down below from that, right here, you can see there is another triangle. This one is a right triangle, though, because this has a right angle right here. There we go, nerd humor right there. Math and heart, remember? This is Triangulum. Triangulum. And right over here in this part of Triangulum is M33, the Triangulum Galaxy. And I think one of our astrophotographers had taken a recent picture of the Triangulum Galaxy, right, astrophotographer?
Why, yes, I did.
Okay, good. So you will see the Triangulum Galaxy later on in detail by our trusted astrophotographer. And that's a great object to look at as well. It's supposedly, according to George Lucas said that the Star Wars universe is held in the Triangulum Galaxy. So whether or not that's true, we don't know. It happened a long time ago in a galaxy far, far away. Okay. Yeah, just make sure you're awake, a little bit, awake for the rest of the program there. All right, so what we're going to do is we're going to continue to move forward. Now we're going to bring the east directly in front of us here. So everyone tell me what this constellation is. Go!
Pegasus.
There we go, Pegasus. Thank you, Bob. Thank you. Pegasus. And bonus question, anybody know the name of this star? Alpheratz. Alpheratz. And then does anybody remember the name of this constellation? And this right here? Andromeda Galaxy. 2.5 million light years to be exact, all right? So pretty far away. Now what I'd like everybody to do is we're going to continue on this way, and we're going to find this group of stars right here. That is Cassiopeia, or Cassiopeia. Tomato, tomato, all right? They're both correct. So we're not going to start a war on which one's right. They're both correct, okay? So just accept it. Cassiopeia, Cassiopeia, whatever you like. All right. Now, what we usually pick out here is an M or W. Or if you're a Harry Potter fan, I call it the Harry Potter lightning bolt. All right, it kind of looks like the Harry Potter lightning bolt. Or if you're a math geek, this looks like a sigma a little bit. Okay. So in Cassiopeia, we have a lot of cool stuff. We have the Bubble Nebula. We have the elephant trunk. We have lots of different other objects surrounding that area of the sky. Great to photograph, great to observe. The jellyfishes in Gemini. I excuse myself on that one. But there's a lot of different things, including not too far below in Cassiopeia right here is Perseus. Perseus, the Greek hero. Now, since we're getting closer to Thanksgiving, the easiest way to pick them out is a turkey wishbone right there. You see the wishbone shape? Or it kind of looks like a, whatever. Doesn't look like a guy, that's for sure, okay?
Big letter K.
The big letter K, that kind of looks like a K there. I can see that, yeah. Kind of a lowercase K. But this bright star right here is Algol, which literally means the ghoul or demon. This represents the eye of Medusa. But also, if you were to make an observation of Algol, you would notice that the brightness, the magnitude, the brightness of that star will increase and decrease over about 4 days. So that's because it's a variable star. It has an eclipsing binary around it that brightens and brightens the star. Very, very nice object to take a little bit of if you're getting into variable star observing. That's a great one to start out with. Right in between Cassiopeia and Perseus, right in this part of the Milky Way galaxy, is a very nice cluster of stars called the double cluster. Now the double cluster is that it is. It's a double cluster. But both clusters are about twice their distance. One of the clusters is 16,000 light years away. The other one is 8,000 light years away. So they may look like right next to each other, but because it's, they're actually double in distance from each other. And that can be seen just in between Cassiopeia and Perseus, right here, just kind of in Perseus's helmet right here, right there. A lot of people see it as kind of a, like a Greek helmet with those kind of like bushes or whatever they have, the little things on there, feathers, I don't know what they are, but that would be kind of where the double cluster would be. Now, rising here, just kind of around 10 o'clock, 10:30, we can see the Pleiades. If you go here, you can see that Perseus's body kind of points down to the Pleiades, a great cluster, open cluster of stars to look at, even with a tiny telescope. If you have one of the smaller, like Astroscan style telescopes or a smaller refractor, that's a great object to observe in the sky. Great area to photograph. And over here, we have the star Capella, not acapella, but Capella. That's a good way to remember it, though, if you remember acapella. And that's a nice star in Auriga the Charioteer, or we call it the Pentagon, the space Pentagon, right there. And all throughout Auriga are these beautiful clusters, M36, M37, and M38. And these are very easy to see, even with a pair of binoculars. And you can actually see them with your naked eye if you know where to look. And you can see just at the horizon we have Orion beginning to rise in our sky. And we're going to finish up our tour here with the north. All right, we got to finish up our tour with the north here. And we can see that the north right now is kind of lame. Right now it's not as exciting as it usually is. The springtime is the best time to really look at the north because you have Draco and all this other cool stuff up in the sky. But one of the things I want to point out right now is here we have Cassiopeia here, and we can use this star to point to Polaris, because why is Polaris important to know? Well, that's what you align your mount to, right? Yeah, it's very important to know where the North Star is. And it surprises me how many people think that the North Star is the brightest star in the sky. Of course, we all know that's not the case, right? Of course. What is the brightest star in the sky?
Sun.
The sun, yeah. The sun, so bright you can't even see it. Now, if you said Sirius, you are correct if I asked what is the brightest star in the night sky. So, but if you follow the North Star thing in Sirius, you'll get in some serious trouble, But you can't see it right now. You can't see it. It's just not up. But it's really crazy. We were looking at the sun at Maker Faire this weekend, and we would tell people we're looking at the brightest star in the sky, and people would ask, what is the brightest star in the sky? And they would realize it's the sun, right? Polaris is actually 50th in brightness, just to give you an idea. But of course, Polaris makes it important is because we point towards Polaris in the northern hemisphere, particularly our North Pole, and everything pivots around the North Star, which of course, now technically our North Star does move a little bit in the sky. That's why when you use your pole scope or if you have a pole scope in your telescope mount, you'll notice that there's a circle because Polaris does in fact move around in the sky. So you want to line it up to that circle to be able to compensate for the actual slow movement of Polaris in the sky. Just by the human eye though, we can't notice that. And this right here is our Little Dipper. There's the bowl and the handle of the Little Dipper, but this also is part of the Little Bear, Ursa Major. There's his nose, his body, and his tail. And we can see a little bit of Draco here, but just his little tail. And again, it's not as exciting as it is in the wintertime. So I don't want to inundate all of you with lots of other constellations and lots of other astronomologies, but I just wanted to kind of give you a general area, a general overview of what's up in the fall time skies, and for you to kind of use this as a starter to get yourself going when you go out and observe. Maybe you're doing outreach, and if somebody asks you, hey, what's that constellation up there, you can point it out to them. Or just for general, casual observing, you have a better understanding of where everything is in the sky. So I hope that you all enjoyed my little tour of the night sky, and yeah, that's it. So we're going to do the worst part of the tour right now, and that is the lights. But because we're astronomers, we're going to start with some red light first. And I don't need to explain why red light is important. You all know why red light's good. Yes?
Why is red light good?
Oh, why red light good? Well, so your color receptors in your eye don't see red as kind of like we need to dilate our eyes.
Okay.
So red light allows your eyes to remain in dark adaptation mode.
Okay.
Which is really good for when you're at night. So it's actually encouraged to use red light at night. It makes it easier, safer to walk around if you have to use the bathroom or go to the kitchen to grab a midnight snack or something like that. But yeah, so I encourage all of you to consider using red lights. Now with the advent of red LED technology, I changed all my interior lights in my car to red. So I mean, I'm like that weird person. But yeah, so that's one of the reasons. So we're gonna keep our eyes on this light for a little bit here. We're gonna bring the rest of the light up. So watch your eyes. We're gonna keep it in there for a little bit. So yeah, there we go.
Very good job. Brings me back to my childhood when I went to my first planetarium show. I hope I never outgrow the good old-fashioned planetarium show. So our next mini program, you can notice I'm not bothering to get up, is because Bob Vogel is going to give us our constellation of the month.
Okay, so real quick, I had to turn out the projector, so it's going to take a few minutes to reboot. So
we've got to reboot.
Well,
now I got to stand up and.
Yeah, I'm sorry. We should have done this last.
All right,
it's all good.
So I'll start the conversation, and about the time we get 3 sentences in, he'll be ready. That's usually how that works.
Oh, he has.
Oh, Christmas telescopes. Okay, so anybody disagree? I think hey, I kind of want to get a telescope. If you had to pick a telescope to give to somebody, I would probably choose a Dobsonian. I think it's the easiest to operate. Even if it's poorly collimated, it's still quite serviceable. It's hard to get a lot of people want something that looks like a refractor because it looks like a telescope, but it's really hard to get a good refractor for a Christmas budget that when you look at Jupiter or something, it doesn't look like an airplane lights with red, green, and blue or something. So I always recommend a small dot. They come in all sorts of price ranges from under $100 to several thousands of dollars, depending on what your budget is. Does anybody know what I should mention? What this is, if you don't know, this is a Dobsonian. And what that means, the Dobsonian name comes from the type of mount. Basically, he's got it locked. It spins this way and it tilts up and down. So you just basically move it and point it at what you want to look at. And there's usually a sight of some sort where you can look down. Don't need a computer. You can put in a low power eyepiece and get a wide field so you can see star clusters, works great on the moon. You can even spot the planets. You're probably not going to do real high magnification with the dot, but there's all sorts of interesting objects that you can look at, even in a light polluted area. And if you take it somewhere dark, like Geneva or KPP or Chiefland or someplace away from city lights, there's a large number of objects that show up very well in a Dobsonian telescope. They make them so big, you need 3 people to get them off the back of your truck, and they make them so little they'll almost fit in your glove compartment. So they come in a wide range. But it is, in my subjective opinion, I think it's like the easiest easiest type of telescope to learn to use. Are we there?
We
there
are
yet?
ready. We're ready.
All right, I've killed enough time. I'll let Bob have this and let him drive.
Thank you, Richard. Good to be here again, and tonight we're going to have a little homage to Glenn Campbell. We got, by the time I get to Phoenix, she'll be rising, and we'll be about 2/3 of the way through the 88 constellations that I have been tasked to present over these past several years. And so Phoenix, as of course the story that most of us are quite familiar with in mythology, the immortal bird that bursts into flames and is reborn from its own ashes. And been depicted in a great many of different artistic representations and various stories. It all began astronomically with some of these gentlemen here. On the right we have Frederick de Houtman and Peter Kaiser, were two Dutch navigators that in the 1500s were navigating throughout the southern seas, principally the Indian Ocean, and were mapping star constellations, star groups that had not been seen and mapped before by European people. So obviously they were well known to those indigenous to the southern hemisphere, but this was all new stuff at this time for Europeans. And so these guys brought back their maps and their notes on what it is they had observed, and gave much of that information over to the gentleman on the left here, Petrus Plancius. He was a Flemish map maker, and he did both celestial as well as terrestrial maps. He also worked with many explorers like Bering and Hudson and others who were exploring in the northern hemisphere, and he drew out maps based on their finding as well. But the majority of these constellations that were then developed out of their work were named after recently identified birds and animals. And it was later on that Johann Bayer, a German astronomer, included many of these new star patterns in his Uranometria celestial atlas, published then in 1603. And these, the list of the constellations, these star patterns that had been identified by these explorers and subsequently put into these maps. And so we'll be getting into these others here as we continue our trek into southern skies. But we see here the Phoenix as being one of these, and as you can see, there are some, virtually all of them associated with some sort of new birds, birds that were new again to the Europeans at the time, and other animals of sorts. Here is the depiction from Bayer's atlas, the Uranometria. This is the southern birds, many of which we can see here, the peacock among them. And of course, here is the Phoenix on the lower left, depicted from his atlas portrayals. Another depiction of the Phoenix here comes from Johann Doppelmayer's Atlas Celestis in 1742. Kind of a striking depiction there of the bird in flames. Actually, the notion of the Phoenix was even picked up in Chinese mythology, going back to a time when they developed their own zodiac, in which the 4 seasons were divided amongst 4 principal characters, one of them being the vermilion bird, which would be associated with the Phoenix mythology. And each of these areas was subdivided then into 7 different mansions, they were called. So you had, in total, there were 28 official areas or constellations in Chinese mythology at this time. So now, to kind of orient ourselves, we've just taken a look at the night sky and pointed out that the cornerstone of the autumn sky is the Great Square of Pegasus. It's directly overhead at this time of year. That's just above the ecliptic, passing here just below it from the west on into the east here. Along, of course, we got Capricorn, Aquarius, Pisces being the principal zodiacal constellations of this time of year. Again, Andromeda, as was pointed out, going off up into the northeast. And so this is the area of the sky, of course, most of us would spend our time looking at. We can see that Phoenix, from our latitude, is theoretically visible, but it's very, very low on the horizon and not going to be something that's going to be very easily observed or imaged in. And so obviously the further south you get, the better off it would be. So you think, well, okay, so I'll make a point of checking this out when I go to the Keys for the Winter Star Party. But alas, Phoenix will not be up at night during that time of year. You would, that's usually what, in January, February, so the Winter Star Party. And unfortunately, it's only, it will be up in the daytime during that time of year. So you really have to be able to look at it in the fall. Now would be the time to go down and see, you might be able to get some images of it there. This gives us an area that we're looking here at. Phoenix is ranked 37, so it's kind of a middling sized constellation. And without any particularly bright star pattern associated with it, there's only really one particularly bright star, Enka, which is, but still, if we were to look at it in this time of year, if you're looking to the south, you may see Fomalhaut, but it's up at around minus 30 degrees south latitude, and this, as you can see, is about 10 degrees or more further south than that, and not quite as bright. So Enka is not going to be a star that's going to really pop out to us, although it is the alpha star here in the pattern that would be defined as Phoenix. And here's again the official IAU outline of Phoenix as it would appear on their map. So what do we get to look at? If we were able to see Phoenix a little more overhead and had what kind of content might we want to search for? It's a little sparse. It's not in the galactic plane. It's not anywhere near the Milky Way or anything. So there's no bright star clusters to be noted here. We do have this dwarf barred. Sorry, wrong button. Barred spiral galaxy. NGC 625, a member of the Sculptor group, which is a loose group of galaxies near the South Galactic Pole. It's about just under minus magnitude 12. So nothing particularly much to look at there, but might make a challenging image. A little more challenging, NGC 37, a lenticular galaxy. This is approximately 137 light years in diameter. So we're looking here, although it's at such a distance, almost 13 billion years old. So we're looking at something vastly far away, as we can see by this very pixelated image that we have of it there. But this is that would be larger than our Milky Way, or fairly comparable to it. So, but not much to be seen in this particular image. If we keep going, we've got next over. Now this would be the showpiece item. The reason that you would want to do any kind of imaging in Phoenix would be to go after Robert's Quartet. And this would be kind of likened to the other great collection, the Stefan Quintet, which is what, in Virgo? Mm-hmm. Yeah, okay. And it's very commonly imaged by northern observers. But here we have a nice, lovely collection of 4 galaxies that are associated with one another, and because of their association, have a creation of some 200 star-forming regions. And you have this stream of gas. I think it doesn't really appear. I think it's here. It's kind of coming down in this area here. You have this stream of a tail of gas that has been pulled away from one of the members as a result of the interaction of these galaxies with one another. So they're comprised altogether of NGCs 87, 88, 89, and 92. They were discovered by Herschel in 1834, and as you can see, kind of dim at almost a 14 magnitude, but a nice grouping of different types of galaxies that would really make a nice image to go after there. as is the Phoenix cluster. Now, this is a massive Type 1 galaxy cluster detected just recently, 2010, and by a collaboration of telescopes, the South Pole Telescope, and this is a vast halo of gas around the central galaxy. But as you can see, there's this beautiful chain of galaxies here. There's a curvature, that get to be picked up here. And if you kind of include these top up here, you kind of have like a numeral 5 here, and it's beautiful. So that's really, and all these other background galaxies. This, really quite a captivating image of this particular cluster. One of the largest galaxy clusters that have been found. It's thought to be about 22 times the diameter of our galaxy, and a lot of starburst activity associated with it. But as large as it is, it can be bested by El Gordo, or the Fat One. This is the largest galaxy cluster discovered with a mass of 3 quadrillion suns. So we're looking here. This was found with the work of NASA's Chandra X-ray Observatory, as well as the Atacama Cosmology Telescope and the European Southern Observatory's very large telescope. So this is over 7 billion light years distant. So we don't get a great deal. It almost takes on sort of a cometary appearance here with a coma and the tails that you might imagine from that. But of course, this is vastly larger than that, of course, and hence the name El Gordo. So that would be a nice take for someone wanting to take a picture of something very, very big. And and we'll finish up here with just some of the artistic depictions of the Phoenix that have been brought about. This was an etching created by Friedrich Bertux, a Kinderbuch. This is a children's book of mythological creatures from 1806. And then finish with this rather more modern optical appearance here, some visionary art by an artist by the name of July Lama. So, and that you can kind of really see the Phoenix peering down on you. Beautiful and very colorful image. So I hope that you will enjoy taking a look at Phoenix, and when we're ever get a chance to go south this time of year, it'll be something we can take a look at.
That's really cool. If I ever get a chance to go south, there's definitely some stuff in there I'm going to consider shooting. Next up is Derek is going to showcase some astro photos sent in by members every month. We have a pretty strong core of astrophotographers. It doesn't have to be an astro photo. It could also just be a group. I think we should also include pictures at outreach events and CFAS activities as well, so we can highlight things that our members are doing in the month between when we get together here. And are you ready to go, Derek?
I am ready.
All right, then I'm going to shut up.
Silence, Richard. Okay. So, yeah, Richard's correct. Actually, some of the photos in here are not technically photos of the night sky. In fact, some of our members send me pictures that have nothing to do with particular space objects. But tools that are used to look at space objects. One of them, our CFAS member, Sharif, has visited a couple of interesting areas in terms of astronomical research, correct? So I'm going to go ahead and bring up this picture. Just like for those that have not been here to see one of these, anytime you see a picture up there, if it's yours, if you could just talk a little briefly. You don't need to go into really intense detail of how you took the picture. Just a little bit about what it is, and maybe some of the equipment used and things like that. So yeah, we're going to start with this picture right here.
So about a week and a half ago, I went out to Wallops Flight Facility for a NASA social event, and it was to see the Cygnus cargo launch for the International Space Station on the Antares rocket. Part of the tour that they gave us of the facility was to go see the near-Earth network satellites, and where they have the NOAA set up. And this particular satellite was used in the Apollo 11 triangulation of the rocket. They have one in Wallops, and they have one in Hans Inlet, I believe is what they said, and then the other one at Kennedy Space Center. And so they talked about all the satellites that was up. It was pretty neat to share that. And there was beautiful evening. The moon was just above, which
Yep.
Yeah. So yeah, the other picture is just some of the other ones, and then out in the runway there is some of the other satellites that are on launch. So if you're ever out in that area, definitely go take a look. It's a neat area.
All right, thanks, Sharif. Speaking of satellites, dishes, and stuff, I'm a member of the Astronomy Educators of Chile Ambassadors Program, and also part of the program is we get to tour United States observatories. So we got a chance to do a tour of the Very Large Array, or actually the Carl G. Jansky Very Large Array, and we had an opportunity to go out at night and
Caught the belt of Venus there very nicely too.
What was that?
The belt of Venus.
Belt of Venus. Oh, okay.
In the on the horizon.
Yeah. Okay. Yes.
Yeah.
Belt of Venus.
Which is the shadow of Earth as sunset.
The shadow of the Earth. The shadow of the Earth as sunsets. Exactly. Yes. Thank you, Bob. Thank you.
Okay.
No, it's great. It's great. It's good to add that in. Thank you, Bob.
Extra points. It was also an astrophoto.
It's an astrophoto, exactly. So a group of us went out at night, and then the temperature at the night was about 25 degrees. This was early October, and the telescope, or the particular satellite dish that we were able to, radio telescope dish that we were able to photograph, wasn't in line with the Milky Way, so it was in line with the north. So I decided, you know what, I'm going to go ahead and do a really cool star trail of this. So there we have our radio telescope. There is actually in the D array, which is actually the farthest array. Actually, they get closer and farther depending upon what they're interested in. If they want big details, they spread out the dishes. If they want very small details, they put them together. So here's a cool little shot of that. Another interesting thing, I don't know if all of you are aware, but the Very Large Array is actually moving forward in what's called the NG VLA, which is the next generation VLA. The next generation VLA will have an array of radio telescopes that will span the entire United States and making one giant telescope. So I think it's going to be really incredible. People ask, what's the VLA doing anymore? No, they're doing some incredible stuff, and the future looks very bright for radio astronomy. And now, one of the questions that was brought up during the time I was out there was, how does the VLA going to cope with Starlink when it comes to communication satellites? And right now, the FCC has approved that anywhere along the range of the radio satellites, they have to cut off transmissions. So at least for the VLA, it's protected. So anytime it passes in front of areas where the VLA is doing work, the Starlink satellites have to turn off. So they are supposed to be based off federally regulated to do that. So that's at least good for the VLA. Whether or not that will happen with other radio telescopes around the world, that's up to the determination of that government. So those are some ground-based astrophotos, and I took this, by the way, with a Canon 5D Mark IV with a 24mm lens, and just took about 200 exposures over the course of an hour and a half or so. There's about 20 seconds each of those exposures there. And one of the techniques you can do is, if you take those photos in Photoshop, you can layer stack them and get the star trails. Now, we just had a little tiny event on Monday. Very tiny, literally. So this was, of course, the Mercury transit. And a lot of you were out and taking photos. So I wish I could promote everyone, but we usually do a call out for photos. So I made sure to show off every photo that was sent to me. So if you do see your photo, go ahead and shout it. I think there's one photo in here that I think the person's not here, so I think it's the first one. This was Mark Femininio's photo. Unfortunately, he didn't give me much information. He just said, hey, this is a crappy photo, and I don't think that's the case at all. But, you know, some people are very modest about their photos. I think it's pretty awesome, the fact that you get this nice spherical, or nice circular, nice view of Mercury. So you did a really good job with that. Again, unfortunately, the tech details were not published, so I'll have to ask Mark for, if you're interested, you can always ask Mark next time you see him about what he took with that. The next one is from, I believe, Debbie Vaughn. Is she, I don't know if she's here or not. Oh, okay, sorry, yes. Can you talk a little bit about this real quick?
Well, I'm an amateur, and I got lucky.
All right, well, that's all you need. That's all you need. A little luck and a desire to photograph. That's all you need.
We had our connected to our telescope. Which one? Me. LX. What's it, 10-inch?
All right.
Yes.
Excellent.
That was the big blue.
I heard that your telescope was on fire, literally. Not literally on fire, figuratively on
Actually,
fire.
with our filter.
Everybody loved your telescope. I heard a lot of people say how much they enjoyed your view of the Mercury transit. So thank you for being here.
Oh, you're welcome.
And then I think this is Luke's photo, right?
Yeah.
Okay, Luke, can you tell us about this?
That's the first light of my new the Southern telescope, and the picture was commissioned by my daughter. She used the iPhone.
All right, iPhone. I'm telling you, smartphone photography is getting better and
There
better.
were some clouds on it, and so fortunately the dot is visible.
That's all that matters. As long as the dot's visible, we're good. John, I think this is your photo, right, John?
Yeah, that's a really, really tiny Mercury in the bottom left there. Again, that's iPhone photography through the eyepiece of my ETX 80 refractor.
Excellent. Yes, I know. Thank you, John, for being there too. A lot of people really enjoyed seeing through yours as well. I think this is a video. Debbie, I think you sent this as well. I think so. There's two videos. I think this is one of these. I don't know if you can see the Mercury now, but the next one is exciting. So let's get a little background on this video. So we were at the tail end of the event, and it was getting really, really super cloudy. And this lady stood at the telescope for probably 30 to 35 minutes, and she was determined to see Mercury. So I think in the audio here, you can actually see us, or hear us, just clap and get excited that she could see Mercury through the telescope here. You got it? So, she said she traveled just to see the Mercury transit, and she just, every time she just couldn't see it, and she finally saw it, and it was like, this is a photo I took with a Celestron 11-inch through a Pixel 3 camera, my little smartphone of Mercury, as it just was heading out. So again, it's amazing what we can do with our smartphones these days. I actually had a telescope fully set up to ready to go, but when you run an event, it's hard to stay around, take pictures, and honestly, this picture I was happy with it. So as long as I got this picture, I was good. And then we have this one. I think is Debbie Vaughn's. You captured literally the last
exit.
The exit, right?
Yeah, that's that. Yeah, 1 of 3.
So I figured this was the last of the photos of the Mercury transit. And seeing that visually, there was hardly any video, so I actually watched it. It was incredible to see this happen in real time. It was incredible to watch it pass. It was probably the coolest thing of the whole day, just to see it disappear almost like a sunset. It was pretty cool. All right, so now we talked about some terrestrial stuff. Now we're going to move on to deep space stuff, and we have a couple more photos here. This is my recent Western Veil Nebula. This was taken with a William Optics GTF 81 refractor telescope using a cooled Canon 6D camera. So we have this beautiful, various different colors, remnants of a part of the Cygnus Loop supernova event. Now, our final photos are from Frank Kane. Actually, all three of them coming up are from Frank Kane. So, Frank, I'm going to let you. Yes, Luke.
Did you use filters?
No, that was just standard. That wasn't using any filters or anything. We're actually, the color's a little bit off because we're using our Planetarium projector because we're going to be doing a show here soon. So I didn't want to switch it. But if you want to see the better version, I can send you the one with that is a little bit more dynamic range.
Excellent.
And then Frank, can you tell us about this picture here?
This thing.
This thing.
Yeah, so this is my haul from October. This is called the Pac-Man Nebula, and I don't know why it's called the Pac-Man Nebula, because it doesn't look like one to me, but maybe visually.
Well, you can see there's the mouth and the head.
If you say so. But it's really pretty, and this is done using narrowband filters. Equipment was a Skywatcher 190mm Maksutov Newtonian on a MIT mount, and a ATIC 383L Plus camera. It's about 7 hours of exposure time on that puppy, taken from my suburban driveway. So.
All right, and speaking of Triangulum Galaxy.
Yes, as Derek mentioned earlier, this is the Triangulum Galaxy M33, the galaxy far, far away. I did not know that. To me, it's the home of E.T., the extraterrestrial, so... We'll...
I don't know, I seen a Millennium Falcon right there.
Yeah, could be, could be.
Kessel Run.
Yeah.
12 parsecs.
We got Gen X pop culture references. Yeah.
Less than 12, thank you.
Oh, ooh. Nice. The cool thing, though, is like those red splotches, those are actually nebula in another galaxy. I think that's so cool. And this is just like natural color, so it's like, it's there. I don't know, it just blows my mind. Anyway, pretty cool detail. This is what, 2.7 million light years away-ish, so...
30, I think it's 33 million, 30 something million, I believe. I'll have to look at it.
Yeah, it's our local
It's
group,
far,
so...
It's very far away.
Far away, yeah, cool. And finally, we have, this is called the Deer Lick Galaxy Cluster in the upper right there, and kind of crappy composition because I was trying to capture that largish galaxy up top there, but I got a photo bomb from Stefan's quintet down in the lower left there, so I decided to crop it to include that, and that was also mentioned earlier. This is cool because I'm just happy with how much detail I was able to get on this thing from a suburban driveway. So this is a very, very far distant galaxy. But,
is it just me, or does it kind of look like there's a jet?
Oh, yeah, I see what you're talking about. I did not notice that.
No, that's the seam of the planetarium dome.
Oh.
I'm sorry. I'm sorry.
You discovered a black hole! No. Well, you discovered a seam. Yeah. But yeah, pretty pictures. So yeah, so if you have any questions, catch me afterwards and I'll geek out with you.
All right, well, thank you all for submitting your photos this month. Again, if you have photos, be sure to submit them to me, and we'll be happy to showcase them. So thank you much, everybody.
Thanks, Derek, and everybody who's taking a picture in. There's some very talented people in this club. So next up is our main program, which is Protocol Mercury. And Derek, I presume the same rules apply? You're going to turn the lights off and the doors are going to lock down?
Yes.
Okay.
So, I'm sorry. You want to take a quick break?
I hate to take a break because somebody could get locked out, but if we have time and you can be quick, now is the moment to run for it.
Bathrooms are right outside.
The bathrooms are right outside.
Actually, for this show, Justin, we could probably unlock that door.
We can keep count.
Because it doesn't get super
It doesn't
dark.
get super dark?
Yeah,
Okay.
we could probably unlock
All right.
that door and keep. If
So
people
we
want.
will let you
Just
back
be,
in.
just we're all astronomers here. Just make sure that
Be careful, don't
be careful,
fall,
don't
bloody your
fall.
nose, paperwork when we get home tonight.
Use your red lights.
All right. So this is also a good time to come up and buy a calendar. $10? $10? No holiday?
I was up there.
We're going to get started. I'm going to actually run out in the hall real fast just to make sure there's no loiterers. But we are about ready. Sorry. Ready over? Anybody out there? All right, we're gonna leave it unlocked anyway. I don't wanna. Always awkward when you come back and you're sitting right there in the middle of the thing. I'm just gonna run over everybody today. Okay, I am going to turn off the mic and be quiet, and then Derek's gonna give us our show. Thanks, everybody.
All right. So yes, you have to hear my voice one more time. I'm sorry, but oh, thank you for one person. All right. No, so we created a planetarium show for this month, obviously in honor of the Mercury transit.
Justin and I were talking about shows for this month a while ago, and we're thinking, well, how many people really know about Mercury? They hear about this Mercury transit. They might hear about the retrograde of Mercury, and we want to help educate people on and just give them some extra insight on this little tiny world way out there in the inner solar system. And so this show is basically it's a shorter planetarium show, so it's not going to be as long as it's not a full hour or anything like that. So, but this is just a basic little introductory to Mercury and a little bit of kind of what the science we have learned about Mercury and all of that. But we're also going to talk a little bit about the historical aspect of Mercury in terms of what people have learned about Mercury over thousands and thousands of years. I kind of like to do the Bob Vogel approach, where we start off with kind of antiquity and move on to modern day. So basically, Mercury. By a show of hands, actually, how many of you have seen Mercury through a telescope? All right. So there's a statistic that was being thrown around recently that less than 10% of the human population has seen Mercury in the sky at night. And the reason for that is because we all know that Mercury orbits the sun very close, and it's always usually in the glare of the sun, very close to the sun in the sky. So it's very hard for us to observe Mercury, only during a few pieces of time when it's in what we call superior conjunction, which essentially Mercury is at its furthest approach, and so essentially Mercury is, so we actually see it. Actually, there was a few weeks ago, Mercury was visible in the sky right after sunset, but you have to literally have no trees, no buildings, nothing in order to see it. And so Mercury has always been kind of seen as this being, as kind of a wanderer, somebody who disappears, is barely there. So when it comes to antiquity, ancient people, of course, ancient people saw the stars, the planets, and the moon and stuff as supernatural beings, gods, spirits, things like that. They always saw Mercury as this basically wandering object, very flighty, very pretty much not around. So when it came to the Greeks and to the Romans, Mercury was seen, well, for the Romans, it was seen as Mercury, which is the Greek counterpart for Hermes. And Hermes is considered the messenger god of the Olympians. And so essentially, Mercury would travel around, flying around kind of like Peter Pan, all around the world and displaying messages from the gods and things like that. And so in the case of to the Greeks, they said, oh, well, the reason why Mercury is not in the sky or Hermes is not in the sky is because he's off doing, delivering some messages from the gods. So again, that was kind of their justification of why Mercury was barely visible in the sky at night. Now, to the Norsemen, particularly the Vikings, of course, it was seen as Wotan in Germany, but if you are somebody from Scandinavia, it was Odin, yes. And if we all seen Thor, we probably immediately recognize this character, right? Anthony Hopkins as Thor, or Odin. And Odin was seen also as a wanderer. Odin would also disguise himself as a kind of a wandering old man. And in fact, J.R.R. Tolkien based his character Gandalf the Grey off of Odin, because Odin would wander around as an old man disguised and basically connect with humans that way. So Odin was also seen as this wandering object, wandering being in the sky, again associated with Mercury. And when it comes to our days of the week, Woensdag, or Wednesday, became the day of Odin. So next time watch Thor on Thursday, and then watch the scenes of Odin on Wednesday. So to be really serious. So there you go. A little bit of cultural reference. There's tons of other ones, but those are the big ones that are connected to Mercury. Now, I'm sure all of you have heard about that whole retrograde of Mercury stuff, right? And I'm sure a lot of you, do your face palm when you hear it, right? What is this retrograde of Mercury thing, right? People get really crazy about this, thinking the world's going to end. People are going to go crazy. The internet's going to go down when Mercury retrogrades.
the cat videos are ending on the retrograde of Mercury. The Golden Corral's closing on the retrograde of Mercury. Lots of crazy things occur on the retrograde of Mercury, right? What is this retrograde nonsense? Well, we all know that I don't have to spend too much time explaining this in the normal planetarium show. I would. The planets all orbit around the sun, and what we're going to do right now here, I'm going to go ahead and kill these bottom lights here. What we're going to do is we're going to go ahead and target the Earth. So let's do that, and then we're going to go ahead and leave the Earth behind. So we're going to go ahead and move our Earth away, and we're going to go ahead and look towards the inner solar system here. So as I back away, eventually we'll see the sun. So I'm going to go ahead and target the sun now. All right, so of course we all know that Mercury is the first planet from the sun, and so the Mercury being the first planet from the sun orbits around the sun at a faster rate. So think of here's Mercury. Anybody know the second one? Venus, and then there's Terra, Earth. So think of these planets kind of like on a racetrack, right? They're all zooming around, right? So what I'm going to do here is I'm actually going to speed up time. We're going to go ahead and speed up time here. Let's go 30 days a second. You ready for that? 30 days a second, because Mercury goes around very fast. So here we go, 30 days a second. Look how fast Mercury is orbiting the sun. Being closer to the sun, it falls around the sun at a faster rate than Earth does. 1 Mercurian year is 87 days. That's it. We would all be very, very old if we were living on Mercury. And of course, since Mercury goes around so fast compared to the Earth, we basically, as we go around the sun, Mercury passes us by multiple times a year, right? Well, as it happens, essentially Mercury heads off to the other side of the sun, and we're still on the other side. So when this happens, it looks like Mercury is starting to move backwards relative to the motion of Earth. And to kind of show you that, we're going to go ahead and go towards this part of the sky. We're going to go ahead and move that here. But you can see that at a time, Mercury appears to move this way, and then from its vantage point, it starts to move this way. You guys see that? It moves this way, and then it moves that way. Well, that's essentially, when we look in 2D space, it looks like it's retrograding. It simply looks like it's moving backwards again, based on its position relative to us as it orbits the sun. So in reality, is Mercury moving backwards? No. It's just passing us by in its orbit. Will the end of the world happen when Mercury retrogrades? No. Because all it is just a point of view from here on Earth. Of course, Venus does the same thing. It retrogrades, and so on. So there we are. That's kind of a little quick explanation of the retrograde. Normally go into a little bit more detail with the public, but of course you guys are astronomers. We don't need to go into details about that. But it of course explains kind of the science behind what we have here when it comes to the retrogrades of Mercury. Now, going back to this, people from all over the world saw this in the sky. Now, if we go back to ancient Greek times, there was this guy named Ptolemy. And for the longest time, Ptolemy's model of the universe pretty much was the #1, model. Geocentrism. Essentially, from his observations, he saw all the planets and the stars and all that go around the Earth. So from his point of view and his observations, it seemed like the Earth was stationary and everything in the sky moved around it, right? Well, people for 1,000 years used that model to describe the universe around them. And one of the things that was hair-ripping, or just hair-tearing, or whatever you like to describe it, just very, very frustrating to astronomers, was this retrograde of Mercury thing. In fact, people from the Middle East tried to tackle the idea of retrogrades, and they came up with some really crazy ways of explaining it. Now, this is called a Tusi couple. Ibn al-Tusi actually created this very elaborate circular motions of the planets that try to describe retrogrades. So he still catered to the idea of geocentrism, right? So here we have the Earth, and here is the orbit of Mercury. And the reason why it has this weird, peculiar circles within circles within circles was a way to describe this retrograde effect. Now, let me ask you a question. Is this really something that's simple, right? So yeah, this is pretty complicated, right? Well, a guy in India, of course, during this time, the Islamic Empire moved into India during this time, and an Indian astronomer, Nilakantha Somayaji, took this idea and said, you know what? What if we were to describe Mercury's orbit around the sun instead of the Earth? And that helped explain this whole retrograde thing, that basically the planet Mercury was going around the sun. But only Mercury. Everything else went around the Earth. It was a good start, right? It's progress, everybody, progress. Okay, we can't just jump the bullet and go into solving issues, but we can build upon it. His ideas, though, traveled from India to the Islamic world. In the Islamic world, we have the rise of the European Renaissance. And a little guy named Copernicus grabs this idea and says, well, what if we were to treat all the planets going around the sun and not just Mercury? So it was actually an Indian astronomer that actually opened the door to heliocentrism because of this little tiny planet Mercury and its retrograde. So even though we give a lot of this ragging on the retrograde of Mercury, you can thank the rise of Copernicus's model, the heliocentrism, on retrograde Mercury. So, you know, you can give that to the astrologers, if you will. So, but anyway, so that's kind of an evolution of Mercury. Now, of course, what did we just witness just recently? Well, we observed a Mercury transit. This was a picture I took during the 2016 one, but you know, it pretty much looked very similar, right? Except for this beautiful sunspot that was on there that day. The sun looked like just a big orange ball in the sky. But essentially, this was really exciting for science. There's a couple of reasons, too. Number one, the transit of Mercury was actually first observed by Galileo. And, of course, Galileo lost his eyesight by directly observing the sun, but he also used the transit of Mercury as proof that Mercury does go around the sun, using mathematical and scientific empiricism to prove Copernicus's model of heliocentrism. So they were observing Mercury transit, so through the process of a telescope, we were able to actually see a Mercury transit, and we were able to prove that, of course, the planets go around the sun. But so since then, we were able to model the solar system in much greater detail. But one of the coolest things when it comes to the Mercury transit that's really interesting is proving special relativity. Of course now I'm having a memory lapse. Back in the 1960s, I believe, or late 1950s, there was a Mercury transit, and they actually timed based on telescopic observation to time on Earth, and found out that there was a delay in regards to the speed of light. So they were able to prove relativistic speed based on the time that we could physically observe Mercury to time here on Earth, and found out that there was a delay because of the delay of the light traveling from the sun, right? Or from Mercury. And there's also a little bit of gravitational anomalies from the sun that actually distort light as well. So they were able to actually prove special relativity by watching the transit of Mercury, which is really, really cool when it comes to physics. So again, Mercury transit, even though it's this little tiny black dot traveling across the sun, has helped pave the way for great advancements in science. All right, so we talked a little about the historical applications of Mercury, talked about a little bit about the Mercury transit. I'm sure we've been inundated with Mercury transit for a while now. Now it's time to go ahead and take our time and explore the planet Mercury. So are you all ready to get going on this trip? All right, here we go. Because, you know, a lot of us are Star Trek. Actually, Frank, you're a very, very good Star Trek fan, right? Would you give us a good Patrick Stewart engage to get us going to Mercury?
Engage.
A little louder, please.
Engage.
There we go. There we go. All right, here we go. We're going to go fly now to the planet Mercury. Now, while we make our way to Mercury, of course, Mercury is about 30 million miles from the sun, give or take. Very, very close to the planet. And usually in the case of the public, I ask them, okay, if we're getting close to the sun, what do we have in terms of temperatures based on how close we are? And of course you would say it's pretty darn hot on Mercury. But what if I were to tell you that Mercury is not only one of the hottest planets, but is also one of the coldest. And a lot of times the public just goes, nah, that's crazy. But actually there is some science behind the reason for that. And what's really astonishing is that we just recently discovered evidence of water ice on Mercury. So this is really, really exciting news when it comes to water in our solar system. So here we are. Welcome everybody to the planet Mercury. Our little tiny world, about 30,000 miles across. Give or take a few a little bit. So just a tad bit bigger than the United States. And a little bit bigger than our planet, or our moon, but about the size of the moon. And essentially, we like to describe that Mercury, and of course I'm making approximations here, so don't get exact numbers, but when we look at Mercury here through our tour here, we can see that Mercury kind of looks a lot like the moon, doesn't it? Just like the moon, our planet is covered in craters. That's because both the moon and Mercury experienced a pretty impactful time called the Great Bombardment. So both Mercury and the moon felt the effects of the Great Bombardment. And right now, planetary scientists think that in the early solar system, there was between 17 to 22 planets in our solar system. But many of those planets went through a collision with another planet. So in the case of Earth, we had a collision with Theia, which eventually developed the Celestia, or Earth, and eventually caused our moon to form from that. And we, of course, some theorists will say that Uranus was hit by an array of planetary collisions, which gave its axial tilt and also its rocky rings. And other events happened as well. But in the case of Mercury being very close to the sun, a lot of those particles, a lot of those pieces hit Mercury, but also there was a small planet that hit Mercury as well, which led to the development of what we call the Chloris Basin, which we'll talk about this in just a few minutes. But essentially, during this time, about 4 billion years ago, the solar system had a lot of space junk, and many of those pieces of space junk hit other planets, including the Earth, and the Moon, and of course, Mercury. So when we actually visit the planet Mercury, we actually can get a better grasp of the early solar system. So when we see all of these craters here, we get a sign that these craters were most likely from that Great Bombardment period of the solar system. And we also know that if we get close enough to the surface of Mercury, we actually find ancient evidence of volcanoes. So we know that Mercury was actually volcanically active for a very short period of time, and it was because of these impacts. The impacts caused a lot of seismic activity underneath the surface. Now, the question is that Mercury is a very tiny little world, but it's also the second most densest planet in the solar system, after Earth. And the reason for that is because Mercury, even though its crust is primarily made up of silicas, similar to the Moon, similar to the Earth, most of Mercury is actually made up of iron. Lots of it, lots of iron. In fact, Mercury has the most iron per volume of any planet in the solar system, even more than the Earth is, actually. And what I'm going to do here, if I can find it, is I can actually take a look. We can take a look at the interior of Mercury here. So here we have the interior of Mercury, and you can see it has a very, very small mantle. Most of it is this nice, dense core of iron. And we do know about this because Mercury does exhibit a magnetic field. Yes, it actually has a magnetic field. Because of the pressure of this iron, just churning iron, just like with the Earth's core, generates a magnetic field. And we also think, because looking at evidence, we found out that Mercury does have a very, 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 very small amount of silica and helium in its exosphere. And the silica has actually been blasted off by the solar wind as it bombards Mercury, and the helium is trapped in the exosphere from the magnetic field of Mercury. So Mercury, even though it doesn't have an atmosphere per se, it does have a very tiny exosphere of silica dust and helium from the sun. So we do have a little bit of evidence, but most of it is primarily iron, and silicas. That's the composition of Mercury. What we do think, though, is that being so close to the sun, Mercury was actually once a larger planet at one time. We think that it could have potentially, as the solar system was forming, it did have a gas layer surrounding it. But because it's so close to the sun, during the period of time when the solar wind was starting to generate in the solar system, the solar wind actually blew off most of the lighter elements in the surrounding Mercury, only keeping the densest parts of Mercury intact. So in a way, Mercury is a skeletal planet of a much larger planet a long time ago. And some planetary scientists think that Mercury could have been a more of a gaseous type Jupiter-like planet in the early solar system, and a lot of that was vaporized away from the solar wind and only leaving a dense iron core after it. Some planetary science thinks though that it was actually more of like a Venus Earth-sized planet, or even smaller, like a Mars-sized planet. But either way, Mercury was most likely a much larger planet at one time because of that silica deposited in the exosphere. So kind of a cool little thing. But we do have some evidence of some major impacts on the surface of Mercury. And one of the biggest impacts on Mercury is the Caloris Basin. So I have it pinned out here. We're going to zoom down towards the Caloris Basin. So located on the surface of Mercury, we have this really large impact crater. You can see it right here. This huge impact crater, most likely caused from a small planetesimal, small planetary body, probably was forming in the early solar system during that great bombardment period of the history of the solar system. Hit Mercury pretty hard. In fact, it hit so hard, it actually produced what's called an antipode. An antipode is a kind of a bulge on the other side of the impact source of the planetesimal asteroid or whatever. And it said it hit so hard that essentially created metamorphic rock or an igneous rock, and we find a lot of basalt rock and other types of rock in the Caloris Basin. We also find out here, if you look closely, these may look like highlands, but these are volcanoes. So we do know that there were cinder cones all forming out here from this giant impact a long time ago. Now, the reason why it's called heat basin or Caloris Basin or Caloris Plantatia or Caloris Planetarium is the greatest extent of the sun's hotspot hits right on the Caloris Basin, and areas of the basin can get up to 1,000 degrees Fahrenheit. Very, very hot. But the average temperature on Mercury is about 800 degrees Fahrenheit, pretty much throughout the day side of Mercury. So again, if you're on the day side of Mercury, you can get to extreme heat. However, since it doesn't have an atmosphere, it lacks an atmosphere. Essentially, if you head towards the night side of Mercury, all that heat from the daylight, from the sun, escapes out into space. And the temperature drops from 800 degrees on one side to minus 279, 280 on the other side. So you want to probably live right here. And I think it was you, Frank, were you telling me about the book, Kim Stanley Robinson?
Yeah. 2312.
Yeah, there's this science fiction story that a city is built on Mercury along the Terminator line, and it's on a rail system, and as the planet Mercury rotates, the city actually rotates or moves on that rail to stay in that termination line. And there have been talks about that as well. I read some more about it. There are talks about doing something similar to that on the moon. What's really interesting is that Mercury's orbit is shorter than its day, because it actually has a similar type, synchronous type orbit like the moon is. It's tidally locked to the sun, so it's very slow in terms of rotation as well as it orbits. It's not quite synchronous because the day is actually just a little bit longer, but a very, very slow rotation on Mercury as well. Now, one of the most interesting things that we have learned about Mercury is through Messenger. Messenger was a spacecraft. I'm sure some of you were here when one of my friends, Mark Cockday, he was a mission operator for the Messenger spacecraft, came and visited a few years ago to talk about Messenger. But Messenger was our most up-to-date mission to Mercury, spent a lot of time on Mercury. Again, learning a lot of the different science that I just explained, learning about the formation of Mercury and all that. But one of the things that I just recently discovered about Mercury is this. Near the poles of Mercury, in areas where you have permanent shadows, they were able to actually find residual areas of ice, water ice, in the poles. So in areas where it's perpetually dark at very, very cold temperatures, there can still be remnants of ice. Now the question you have to ask is where does the water ice come from? We tend to find very little to no water in the very innermost solar system. And we think that the best source for that has to be because since Mercury is so close to the sun, we see a lot of evidence of comets. Comets get very close to the sun during their perihelion, and some of that water essentially falls onto Mercury. A lot of that water falls onto the surface of Mercury, maybe in the night or in the day. It will evaporate, but some of it might get deposited over time in the polar regions of Mercury and might stick. And if it is comets, then that means that comets also contain organics and also contain other ices that may potentially harbor life. So I'm not saying that there could be life on Mercury. There could be some organics and things that could have helped develop bacterial or microbial life in those craters on Mercury. But I'm pretty sure that the solar wind from the sun will probably sterilize the life because of the sheer amount of radiation coming from the sun. But it's still fun to think about the idea that there could be deposits of organics and things like that on the surface of Mercury from comets like ones that we see from far, far away. So either way, though, Mercury is this little tiny world. Has really kind of surprised us over the years, and actually there's going to be future missions to Mercury to learn more about the formation of the planet, to learn about the early part of the solar system. And so I hope that when you observed the Mercury transit this past Monday, that hope that this program has helped you get a little bit of extra appreciation for this tiny little world in the closest parts of our solar system. So I want to thank you all for spending a little bit of time here with me exploring Mercury. And again, thank you very much, everybody. All right. And we're going back to those red lights again.
About a question.
And questions, yes, questions. Now, I'm not a...
The magnetic field around Mercury actually provides a bit of protection from the CMEs.
Yeah, but nothing like the extent of our magnetic field. It's not as strong, but it does provide. But of course, there's no atmosphere, and there's not. It doesn't really, have any. Now the question is does Mercury experience auroras? No, because it doesn't have an atmosphere to create auroras. Any other questions?
Is the core actually rotating in there at all?
It is, yeah. We think that it's very similar to the Earth's iron core. It does churn. And that's what we think. And actually, some planetary scientists think that Mercury is basically mostly just a core of a bigger planet with a crust of silica. Of again, much larger planet at one time in the early. That's what that next. I can't remember the name of the mission right now. I should have wrote it down, but there's another NASA mission that's being proposed to go back to Mercury, and that's one of its primary missions is to learn more about the evolution of Mercury.
Sci-fi story idea. Ancient civilization invents new energy form, doesn't follow all the safeguards.
and Mercury's the result.
All right, well, thank you, everybody. That concludes our meeting. I look forward to seeing you then next month. Same bat time, same bat channel, but over at the Student Center for the holiday party starting at 7-ish, maybe a little earlier. If you want to show up and goof off a little, that's fine. And I'll see you then. Thanks.
All right.